Questions 11 through 20 on the 2003 Grade 10 AMC 10A. The sum of two 5-digit numbers AMC 10, AMC 12 is 123422. What is A plus M plus C? AMC 10 plus AMC 12. And they're saying this is equal to 2, 2, 4, 3, 2, 1. Okay, let's take this one step at a time. 0 plus 2 is indeed 2, so that's fine. 1 plus 1 is indeed 2, so that's fine. Now we have C plus C is equal to 4. So perhaps C could be equal to 2. Okay, let's keep that for now. Then M plus M is equal to 3. But M is a digit. So if M plus M is equal to 3, that means 2M equals 3. M is equal to 1.5. And that can't work because M has to be a digit like 1 or 2 or 3. So C is most likely not 2. No problem. Let's keep going back and see what we get. How can we get C plus C equal to 4 if C is not 2? Well, C could be equal to 7. And if it is, it would be 7 plus 7, which is 14. So the 4 would indeed go there, but then you'd have to carry a 1. Correct? So now we go back and look at the m's. So it'd be m plus 1 is equal to 3, like this. And therefore, you can easily figure out that m is 1. So we got C equal to 7, m is equal to 1. Now what about A? A plus A is equal to 12. Well, obviously, A is equal to 6. So therefore, A is equal to 6, M is equal to 1, and C is equal to 7, and they want A plus M plus C. So that would be 6 plus 1 plus 7, which is 14. So 11, the answer is E. A point XY is randomly picked from inside the rectangle with vertices 0, 0, 4, 0, 4, 1, and 0, 1. What is the probability that X is less than Y? So let's draw a little diagram here. It's labeled the points. We got 0, 0, so that's the origin basically. And then 4, 0, so somewhere here. 4, 0. 4, 1, so approximately here. And finally 1, 0, so about here. And this is a triangle, rectangle. Right, rectangle. Gotta know my shapes, right? And they basically want you to figure out what is the probability that if you pick any point inside here, that the x-coordinate is less than the y-coordinate. Well, how do you do that? Well, definitely you will need to draw that line. Y is equal to x. All right? That line is going to definitely be of great importance. And you can draw that line pretty quickly. All you need is 2 points. I'll choose 0, 0 and 1, 1. How about that? That should be enough. This is 1, 1 right there. Join those 2 points and you've got y is equal to x. So basically a line like that. Okay? Now, what are they asking in terms of this diagram? What is the probability? Basically what they're saying is, look, you take a point somewhere, anywhere in this box, this rectangle, right? And let's say the point is here, xy. Is y greater than x? Or is x greater than y? And in this case, it won't be. The only way x will be less than y is if that point is here, right there. Somewhere in this region right there. And you can verify that. For example, let's just say we chose a point right here. It's approximately a half and about 3/4 for y. Is x less than y? It is. You see what I mean? The line y equals x is very important because anything to the left of it within that box will satisfy this requirement that x is less than y. All right, so that's all we really need to do is figure out the area of that triangle and then compare it to the area of the entire rectangle. So let's do that. Area of that triangle, 1/2 base times height. Area of the rectangle, length times width. So what is the base here? It's about 1. It is 1. The height is 1. So there you go. We've got the base and the height of the triangle. The rectangle, the base is right here. It's 4. And the width is from here to here, which is 1. So we've got 1/2 over 4 basically. And that is 1 over 8. So that is the probability that if you choose any point randomly inside this box, that x will be less than y. So number 12, the answer is A. The sum of 3 numbers is 20. The first is 4 times the sum of the other 2. The second is 7 times the third. What is the product of all 3? So you've got 3 numbers, A, B, and C, and their sum is 20. They've given you now some relationships. The first number, A, is 4 times the sum of the other 2. So that's how you would write that one. The second term, B, is 7 times the third term, which is C. And they want you to find the product of all 3. So they want you to find A times B times C. So this is the information we are given, so let's proceed. Let's see, what can we do here? Everything we want in terms of one variable, so we can figure out. We already have B in terms of C right here. So if we can get A in terms of C, that would help us. We can plug them all back into there. So let's concentrate on this guy right here. A is equal to 4 times B plus C. Well, the B, I can put in 7C, and that will become 7C plus C, and that is 4 times 8C, which is 32C. So A is 32C. Great, I've got A in terms of C, B in terms of C. I can now plug it all back into this guy right here. So A plus B plus C is 20, and then I've got 32C for A, B is 7C, and then just C. So 32 plus 8 is 40C, is 20, and therefore C is 1/2. Correct? Now B is equal to 7C according to this equation. So 7 times 1/2, so it's 7 over 2. And then A is equal to 32C according to that equation. So 32 times 1/2, so that's 16. So finally, A times B times C, A is 16, B is 7 over 2, and C is 1/2. So this looks like 16 divided by 4, which is 4, and then 4 times 7, 28. Okay, so number 13 is A. Let n be the largest integer, that is the product of exactly 3 distinct prime numbers, d, e, and 10d plus e, where d and e are single digits. What is the sum of the digits of n? So we've got 3 prime numbers, d, e, 10d plus e, okay? And n is basically the product, so d times e times 10d plus e. And then we have to figure out the numerical value of n and then add the digits of n. Now these 3 are all prime, right? So we've got to basically do some trial and error. There's no magical formula here like a quadratic equation or something that you fill these into, unfortunately. This is just trial and error. So I'm going to list some of the first few prime numbers and let's see what we get. And I think that's actually more than enough because D and E are single digits. So I actually don't even need 11 and 13. D and E have to be either 2, 3, 5, 7. So that's good. That helps us out a bit. It's nice that they put that in there. So let's just go with the first one. Let's say this is D, and let's say this is E. Okay, so D and E are 2 and 3. So then what's 10D plus E? 10D plus E. Well, D we set as 2, and E we set as 3. So this would become 20 plus 3, which is 23. Is 23 a prime number? Because D, E, and 10D plus E are all primes. 23 is a prime. So there you go. 2 for D, 3 for E, and 23 for D, for 10D plus E. So we got our prime numbers, and now we just have to figure out N. N is the product. So in our case, it would be 2 times 3 times 23. Correct? 6 times 23, 138. And then they want the sum of the digits of N. The sum of the digits, well, the digits are 1, 3, and 8. So their sum would be 1 plus 3 plus 8, which is 12. And therefore, 14, the answer is A. What is the probability that an integer in the set 1, 2, 3 all the way up to 100 is divisible by 2 and not divisible by 3? So this list has all the numbers in a consecutive fashion all the way up to 100, right? You get the point. Certainly don't need to write it all out. Now we want first numbers that are divisible by 2. So that would basically just mean all the even numbers. So that would be 2, 4, 6, 8, so on, all the way up till 100. 100 being even. And how many of these are there? Well, there's 100 in the beginning. Number count, put that up there. In the beginning, there was 100, right? 1 to 100 is 100 numbers. But now we just took the evens, so we took 50 of them. So these are the good guys. But we want to eliminate the ones divisible by 3 in this list, okay? Because we want to keep this list, but from it we want to eliminate the numbers that are divisible by 3. Okay, numbers divisible by 3 in this list, well, we don't have 3, but we have 6. We don't have 9 because 9 is odd, so it would not be in this list. But we have 12. 12 would be in this list. 15 won't be in this list because 15 is odd, but 18 would be in this list, and so on. You get the point. So how many of these numbers that I just circled are going to be in this list? Pretty easy to figure out. 100 divided by 6, and you take the integer value of that. That's what those symbols mean. And if you do that, you'll get 16. So there are 16 numbers in this list that are divisible by 3. 6 is 12, 18, and then so on, 24, 30. So from this list, I've got to take out 16, and that leaves me with 34. 34 numbers that are the good guys. Now to figure out the probability, we take our good guys, 34, and divide by the total that was in the original set, which is 100. And there you go. That's our probability. And that's not one of the answer choices. Oh, because they're lowering to lowest terms. Okay, so that's 17 over 50. 15 would be C. Oh, here we go. Units digit questions. What is the units digit of 13 in 2003? Power. All right. As I said several times before, units digit questions are very popular on both the Canadian and American math exams. So how do we do these? Well, you have to take 13 and multiply it by itself 2003 times. Well, obviously not. What you do is you look for a pattern. And I usually go up to 8. And sometimes you can get a pattern quicker, but 8 is usually the magic number. So go up to 13 to the power of 8, like this. And then for each, you figure out the units digit, and then you look for a pattern. And I'm just going to write the units digit. I don't really need or care about the number. See what I mean? Now, if you want to write out the number, that's fine. You can. And for the sake of completion, I will. But on a math contest, since you are limited with time, you don't really need to, but we can. So here we go. 13, the number is 13, the units digit is 3. 13 squared, the number is 169. Our units digit, which is what we care about, is 9, right? 13 to the power 3, 2, 1, 9, 7. Therefore, units digit is 7. 13 to the power 4, 2, 8, 5, 6, 1. Units digit is 1. No pattern so far, but that's okay. Keep going. 3, 7, 1, 2, 9, 3 is 13 to the power of 5. Units digit is 3. 4, 8, 2, 6, 8, 0, 9. Units digit is 9. 6, 2, 7, 4, 8, 5, 1, 7. Units digit is 7. And finally, 8, 1, 5. Big long number, 7, 3, 0, 7, 2, 1. Units digit is 1. Do you see a pattern? It's right here. 3, 9, 7, 1, 3, 9, 7, 1. So that is the pattern. It just keeps repeating like that. So how do we figure out 13 to the power of 2003? That's great that we got this pattern, but how does it help us? Well, what I always do is I look at the 4th one and the 8th one, and you see that it has the same units digit. So that means every time the exponent is a multiple of 4, it will have the same units digit. In our case, that being 1. So the first thing you would do is look at our exponent that we want. Is 2003 a multiple of 4? And it is not, unfortunately. But 2000 is. So that means the units digit of 13 to the power of 2000 will be a 1. And then now, to get the subsequent units digits, you just follow the pattern. After 1 comes what? 3. So the units digit of 13 to the power of 2001 will be a 3. After that comes a 9. So the units digit of 13 to the power of 2002 will be a 9. And after that comes a 7, and therefore the units digit of 13 to the power of 2003 will be 7. So 16, the answer is C. The number of inches in the perimeter of an equilateral triangle equals the number of square inches in the area of its circumcised circle. What is the radius in inches of the circle? So first, let's draw this out. So here we go. This is exactly what the question is asking. You've got an equilateral triangle, which I drew in orange, and it has a perimeter. So obviously the sides are the same. I'll just denote them as X. And then you have a circle around it, and the area of that circle is equal to the perimeter of the equilateral triangle. So the perimeter of the triangle is the same as the area of the circle. Okay? So what is the perimeter of the triangle? Well, if X is the side, the perimeter will be X plus X plus X, correct? What is the area of the circle? Well, the area of any circle is pi r squared. And we don't know the radius yet. That is actually what they want us to figure out. So very quickly, we get 3x is equal to pi r squared as our formula. Now, where do we proceed from here? We have to figure out the radius. So to figure out the radius, I'll draw it in first. I'll draw a line from the center of the circle to one of the edges like that. And that represents the radius. Now what I'm going to do is I'm going to complete that triangle. I'm going to complete that triangle by drawing a perpendicular from the center down to the base like that. And that makes a triangle, and it is a right triangle like that. Now this is an equilateral triangle, correct? So that means these angles are 60 degrees. 60 degrees. And therefore this angle is 60 degrees. Now when I cut the angle in half with the radius, this angle in here will be 30 degrees, correct? And then this angle, because the sum of the angles of a triangle are 180, becomes 60. So there you have it, our famous 30, 60, 90 triangle once again. So these are the same concepts that keep popping up over and over again on math contests. So I'll draw that 30, 60, 90 triangle over here because I need to label some things. The ratio of the sides, as I hope you know by now, are 1, 2, and root 3. Now, we don't know the sides, but we do know that this hypotenuse is our radius from our diagram. And we also know that this side is x over 2, correct? Because this whole side is x. And when I drew that perpendicular, it basically cuts that x in half. So there you have it. I've got a relationship between r and x over 2. R over x over 2 is equal to 2 over root 3, because that is the ratio of the sides of a 30, 60, 90 triangle. So solving for this, cross multiply and you get x over 2 times 2, which is just x, root 3r. And there you have it. Now all you have to do is just substitute this back into here, our original formula. And I'll just do it here. So 3x is equal to pi r squared. X, however, is root 3r. So we have 3 times root 3r is equal to pi r squared. Divide both sides by r and we'll get rid of an r on both sides, and leaving just 3 root 3r is equal to pi r. And then solve for r and you get 3 root 3 over pi. And that is the radius, 3 root 3 over pi. So number 17, the answer is B. What is the sum of the reciprocals of the roots of this equation? Now, what do they mean by that, first of all? Well, the roots of the equation, let those roots be r1 and r2. They want the sum of the reciprocals. So the reciprocals will be 1 over r1 plus 1 over r2. This would be the sum of the reciprocals. This is what they want you to figure out. All right? So this is our equation, and it's in a very strange format. 2004 here, x plus 1 over x, like that. Now, obviously, we don't want it in this form. Multiply through by x to get rid of this guy here that's making me feel uncomfortable. So if you multiply through by x, you'll get 2003 over 2004, x squared plus x plus 1. There you go. Now it's in the form of a quadratic. Now how do you proceed? Well, there's a standard way, which is use a quadratic equation, quadratic formula, I should say, to solve for the roots. And then once you have the roots, r1 and r2, you can flip them and add them. But unfortunately, that's a very long way of doing it, because this is not a very simple quadratic. You know, it's going to be laborious, and it becomes a very long process. It definitely will lead to the right answer, but the key issue is time. So to save time, you use a shortcut. And the shortcut is perfectly legitimate, and I'll explain it as follows. If you have a quadratic equation or any polynomial of this sort, the sum of the roots, and some of you already know this, is equal to minus b over a. All right, where a and b are the coefficients. And the product of the roots is equal to c over a. Okay, that's standard. So now what I want to do is figure out this right here. And that, I'll do it up here. We've got 1 over root 1 plus 1 over root 2, correct? Let's do the math here. Add the fractions. So we get common denominator r2, r2, common denominator r1, r1. So this becomes r1 plus r2 over r1 times r2. Correct? Nothing fancy, just added the fraction. r1 plus r2 is the sum of the roots. This guy right here, minus b over a. r1 times r2 is the product of the roots, c over a. And if you invert and multiply, you'll get minus b over a times a over c. And that just leads to minus b over c. Minus b over c is basically this guy right here. You see how that worked out? Done. That's all you need to figure out the sum of the reciprocals, just minus b over c. So here we go. Minus b over c. What's b in our case? B is the reciprocal right here. In our case, that's 1. And then what's c? Well, c is right here. 1. There you go. Negative 1 over 1, which is negative 1. Done. Now, the long way would take significantly longer, and as you always know, on math contests, you are limited for time. So 18, the answer is B. A semicircle of diameter 1 sits at the top of a semicircle of diameter 2 as shown. The shaded area inside the small semicircle and outside the larger semicircle is called a lune. Determine the area of this lune. So if I have this semicircle right here and I subtract from it this region right here, I will be able to get the area of the shaded region. So I'm going to call this cap right here A, right there. And then this, of course, is AS, area of the shaded region. Okay? So therefore, what we are interested in, area of the shaded region, is going to be the area of the semicircle, which is pi r squared divided by 2. This semicircle right here, minus A. And if I can do that, I've got my answer. Now pi r squared, we can do that pretty quickly. The radius is a half. Why? Because the diameter is 1, and the radius is always half the diameter. So we've got 1/2 squared divided by 2 minus that region A, and therefore this becomes 1/4 pi, and then divide by 2, we got pi over 8. So all I need to do now is concentrate on that region, and I'll be able to figure out AS. So now I have to start working on this part of the diagram. So the first thing I'm going to do is draw a line from the center of this big semicircle to the corner right there, like that. And then I'll drop a perpendicular from that point down to the bottom like this. And this, of course, makes a right triangle. Now I'm going to draw another similar line from the center to that corner right there. Okay, now let's start labeling. These are radii, I should say. This is 1, and this is 1 right here. And they've already labeled that that's 1. So therefore, we just created an equilateral triangle. And as you know, the angles of an equilateral triangle are 60. So this is all 60 degrees. And therefore, this angle in here will be 30, since this was a right angle. This is a right angle, and therefore this is 60, since the sum of the angles have to equal 180. So there you go. Once again, we've created a 30, 60, 90 triangle. So I'll draw that over here just to be able to label things a little bit better. And we've got 90, 30, and 60. And the ratio of the sides are 1, 2, and root 3, like that. Now, do we know any of the actual values of the lengths? Ratios are great, but do we know the values of the lengths? And the answer is we do. This right here, from here to here, that is equal to 1. How do I know that? Because it represents the radius, and the semicircle has a diameter of 2. So if the diameter is 2, the radius is 1. And therefore in our triangle, this is 1, the actual value of the length. And therefore, because of the ratio of the sides of a 30, 60, 90 triangle, this will be equal to 1/2, and this will be equal to √3/2. All right? So there you have it. Now we go back to looking at this diagram, and let's see how we can relate this diagram with our famous region A. Well, we first need, of course, the area of the full semicircle. So I'll write full semicircle right there, or big semicircle. So we first need the area of the big semicircle, and then from that we need to subtract 2 pi segments. So here's the big semicircle. We need to subtract this pi right here and this pi. And then we also need to subtract the equilateral triangle, this one right there. And if we do, that will result in our region A. That's the only thing that will be left over. So the big semicircle is pretty straightforward. That's just pi r squared divided by 2. The 2 pi segments, this is the first one right here, and this is the second one. Those pi segments are basically calculated as follows. You take the degree angle of 60 degrees, and then divide by the total degree all the way around of the circle, which should be 360, and that is the fraction of the total area of the circle. And then finally, the equilateral triangle is 1/2 base times height. The base is right there, which is 1, and the height would be top to bottom like this, like that. Now the height we know is the same as this, which we calculated as √3/2. So there you have it. Now I just have to plug in the radii. The radii of the semicircle, or the radius of the semicircle, is 1, since the diameter is 2. And this 60/360 becomes 1/6. And just put 1 for the radius right there. √3/4. And there you go. You've got A. So let's simplify this a little bit. So this becomes pi over 2. This becomes pi over 3. And this is √3/4. Get a common denominator, 3, 3, 2, 2, and this becomes 3 pi minus 2 pi, which is pi over 6, minus √3/4. And that is our region A. And that's it. We've got region A, and now we can finally figure out the region that we are most interested in, which is the area of the shaded region right there. Area of the shaded region is pi over 8 minus A. So finally, area of the shaded region is pi over 8 minus A. So pi over 8, we got minus pi over 6 plus √3/4. Get a common denominator, 6, 6, 8, 8. 6 pi minus 8 pi over 48 plus √3/4. This is equal to minus 2 pi over 48 plus √3/4, which is equal to √3/4 minus pi over 24. Final answer. √3/4 minus pi over 24, and that would mean the answer to number 19 is C. A base 10 three-digit number n is selected at random. Which of the following is closest to the probability that the base 9 representation and the base 11 representation of n are both three-digit numerals? So before I begin, I want to give you a little bit of a primer if you're not familiar with base 9 and base 11. So all the numbers we normally write are base 10, correct? And what does that really mean, base 10? We don't write it out like base 10. There's no reason to. What it means is that 2 times 10 to the power of 2 plus 6 times 10 to the power of 1 plus 1 times 10 to the power of 0. That's why it's called base 10, because everything is based on 10. I'm assuming that's how they came up with that word. So this, of course, is 2 times 100 plus 60 plus 1. So 200 plus 60 plus 1, and therefore that's 261. So that's how you write base 10. Now what about if I had 261 and I want you to write that in base 9? I want you to write 261 in base 10 but convert it to base 9. Well, then it would be as follows. It'd be some number times not 10 this time, but 9. It's base 9 that I want to convert it to. 9 to the power of 2 plus some number times 9 to the power of 1 plus some number times 9 to the power of 0. All right, so that's what they mean by base 9. So this would basically be some number times 81 plus some number times 9 plus some number times 1, because 9 to the power of 0 is 1. And if you do a little bit of experimentation here, you'll be able to figure out that this is going to be a 3, a 2, and a 0. So 3 times 81 is 243 plus 18 plus 0, and that is equal to 261. Correct? But that's base 10. What about base 9? What is the number in base 9? In base 9, it would be these guys, 3, 2, and 0. So 3, 2, and 0 is the base 9 representation. Okay, so I hope that makes sense. And also in base 9, our digits can only be between 0 and 8. In base 10, they can be from 0 to 9, the digits of any number. But in base 9, they can only be from 0 to 8. So I hope that's a little bit of a primer just in case you weren't familiar. So let's go back to the question and start. So they want you to pick a base 10 3-digit number, and then they want you to convert it to base 9 and base 11, and ensure that when you do that, those numbers are also 3 digits. And they're saying, what's the probability of that happening? So let's first start with base 9, and then I will turn my attention to base 11. Okay? So now, you are taking a number that's normally in base 10. Okay? And you are going to convert it to base 9. And when you do, that base 9 number has to have 3 digits. So I'm really interested in only 3-digit numbers. So what I'm going to do is look at how many do I possibly have. And the way I look at that is by looking at the smallest possible one and the largest possible one. That will give me a range. So what's the smallest possible 3-digit number? Well, it's 100, right? In any base, but let's just talk about base 9. Let's not get too far ahead. So if I have a number that's 100 in base 9, what is its value in base 10? Okay, no problem. Let's convert this. So it would be 1 times 10 to the power, not 10. Don't make that mistake, right? It's 9, because it's base 9. I wrote that 9 in there for a reason. And also says up there, base 9. 9 to the power of 2 plus 0 times 9 to the power of 1 plus 0 times 9 to the power of 0. Correct? So this just gives you 81. 81 in base 10. Okay? So if we were to draw a number line, it looks like so far our lowest limit, if you look at base 10 numbers is 81. 81. Okay, let's keep going here. What's the largest base 9 number? If you remember, base 9 numbers only go from 0 to 8 in terms of their digits. You can't use any 9s in a base 9 number. So the largest base 8 number is not 999. You can't have 9s. 888. That's the largest number in base 9. Well, let's convert this to base 10. It would be 8 times 9 squared plus 8 times 9 to the power of 1 plus 8 times 9 to the power of 0. So this is 8 times 81 plus 8 times 9 plus 8 times 1. So 8 times 81 is 648 plus 72 plus 8, and that totals 728. So here we go. We got another number in here, 728. So this is our range so far of our numbers, but only for base 9. We've got to do base 11 also. All right? So let's do base 11 in the same way. What's our smallest base 11 number? Well, it'll be 100. That is 3 digits. So let's convert this to base 10. So we have 1 times 11 to the power of 2 plus 0 times 11 to the power of 1 plus 0 times 11 to the power of 0. So we've got 121 plus 0 plus 0. So there you go, 121 to the base 10. So I'll put that on my number line. We've got another one, 121. And then the final one we need to figure out is the largest 3-digit number. That's base 11. That'll be 999. Let's figure this out. What is this in base 10? 9 times 11 to the power of 2 plus 9 times 11 to the power of 1 plus 9 times 11 to the power of 0. So 121 times 9, 1089 plus 99 plus 9, like that. So this is 1197. So 1197, I put that on my number line. All right, now what do we do here at this point? We got our number line. Which numbers are we interested in? Well, we're interested in the ones that are common. So for base 9, I had 81 as my smallest possible, and my largest I had 728. So here's the region for base 9. For base 11, I had 121 as my smallest possible, and 1197 as my largest possible if we were looking at 3-digit numbers. So this is my region for base 11. Now we look at the common region. The common region is the region we are interested in, because that common region will present you with numbers that are 3-digit for base 9, 3-digit for base 11, and 3-digit for base 10. Then that common region is right here. Right there. It includes everything that we need. So all the numbers in base 10 between 121 and 728 inclusive. So that would be 728 minus 120, which is 608. So that's how many numbers. But we want a probability, correct? Yeah, probability. No problem. We just have to divide this by the total number of 3-digit numbers in base 10. How many 3-digit numbers are there in base 10? Well, everything from 100 to 999. And that would mean, how many is that? 900. So this is the total number, and this is the number that we are most interested in, because these are the numbers that give you 3-digit numbers in base 9 and 3-digit numbers in base 11. So the probability would be 608 over 900, and this is equal to 0.675. 0.675. So let's see. That would be closest to 0.675 is closest to E. 0.7. So number 20, the answer is E.